Next up is question 10. It says, use number 9 part B to show that each of the series diverges. And a reminder there, in number 9 part B, we prove that if a sub n does not approach 0 as n approaches infinity, then that implies that the series of a sub n diverges, and we call this the test for divergence. And so to illustrate with part A, we're looking at the sum of n over n plus 3 as n varies from 1 to infinity. So here's the first few terms: a quarter plus 2/5 plus 3/6 plus 4/7, so on and so forth. Okay, so here a sub n is n over n plus 3, and to take the limit of a sub n as n approaches infinity, I'll go ahead and divide the numerator and denominator by n. So we're looking at the limit of 1 over 1 plus 3 over n, and as n approaches infinity, 3 over n approaches 0. So we see that the limit of a sub n is equal to 1. And so the conclusion there is that since a sub n does not approach 0, this series of n over n plus 3 diverges. Okay. Now, the real rough sort of intuitive explanation to what's going on here is that, look, as we let n get large, okay, a sub n is going to be really, really close to 1. And so as we move further and further out in the sum, the things we're adding up are all really, really close to 1. And there's an infinite number of those numbers. So in that sense, yeah, the sum here is not going to settle down to some finite value. The partial sums are going to grow to infinity. Okay, so this series is divergent. All right, let's look at part B. We're looking at here the sum of negative 1 to the k times the cosine of 1 over k as we let k vary from 2 to infinity. Okay, so here's the first few terms: cosine of a half minus cosine of a third plus cosine of a fourth, so on and so forth. All right, so here ak is negative 1 to the k times the cosine of 1 over k. And to look at the limit of a sub k as k approaches infinity, well, the negative 1 to the k, that's just going to alternate the sign from term to term. And then the cosine of 1 over k, that's going to approach the cosine of 0, which is equal to 1. So put all together, that's saying that the terms of this sequence will alternate between values that are really close to 1 and negative 1. Here's a visual for you of our sequence. So we're bouncing between positive and negative values, and you can see as we move to the right, these things in magnitude are all getting close to 1, right? So alternating between values between 1 and negative 1. So that says that this limit does not exist. And so in particular, a sub k is not approaching 0 as k approaches infinity. So again, we conclude that this series of negative 1 to the k times cosine of 1 over k as k varies from 2 to infinity diverges. All right, that will do it for this problem. Thanks so much.